So let's do a very interesting question that I found. Find the least value of the expression x plus y into y plus z, given that x comma y comma z are positive numbers satisfying the equation xyz times x plus y plus z equals 676. So for this, I have to tell you to notice the symmetry between x and z over here. That is, if you swap x for z, there will be no change in this or this. See, if I swap x for z over here and z for x over here, I'll get z plus y times y plus x, which is exactly the same as this expression. Okay, now if I take this expression, if I swap x and z, I'll get zyx times z plus y plus x, which is exactly the same as this. Okay, so there is a symmetry between x and z over here. And to find the least value, it will be in the point of symmetry, which is x is equal to z. So what I'm going to do is x is equal to z. I'm going to call that as a new variable t. Okay, got it? And I'm going to call the variable y as u, because t works very well with u. Okay, bad joke, sorry. Let's continue. Let's rewrite both of these expressions in terms of t and u. So t plus u times u plus t is the same thing as x plus y into y plus z. So x plus y into y plus z will be equal to t plus u the whole square. And I'm going to put it in a red box. And I'm going to keep it over here. Okay. Now, in the second expression, I'm going to simplify this part and then I'll equate it to 676. I didn't forget, don't worry. I'll get t square u times x plus y plus z. X plus y plus z becomes 2t plus u. Okay, and I'm going to simplify this. So what I'm going to do is I'm going to equate u as kt, where k is greater than 0. So it can be anything, any fraction or anything like that. That's fine. So instead of u, I'm going to put kt here. So I'll get t square times kt times 2t plus kt. And I'm going to take t as common. I'll get t raised to 4 times k 2 plus k times 2 plus k. So t raised to 4 times k times 2 plus k will be equal to 676 as per the question. So t raised to 4 will be equal to 676 whole divided by k times 2 plus k. Now, before I proceed, I want you to note that u is equal to 2k doesn't only apply for this particular situation. We're going to simplify the expression above. Okay, and that will be t plus kt the whole square, and it can be written as t square times 1 plus k the whole square. I'm gonna remove the slant symbol and put an equal to over here. Okay, so x plus y into y plus z became t square times 1 plus k the whole square. Now what I'm going to do is I'm going to take square root on both sides of this equation, and I'll get t square as 26 divided by the square root of k times 2 plus k. Okay, now if you note, t square times 1 plus k the whole square becomes the expression that we need to find. So I'm going to multiply both sides by 1 plus k the whole square, and I'll get 26 times 1 plus k the whole square whole divided by root of k times 2 plus k. Okay, so that's done. So if I find the value of k, I can directly find t square times 1 plus k the whole square, which is the expression that we are required to find. So what I'm going to do is I'm going to call a function f of k, sorry, not x, f of k as 1 plus k the whole square whole divided by the root of k times 2 plus k. Now I don't know about you, if I have a square root in the denominator, I get annoyed. So I'm going to define a new variable g of k as f of k the whole square. It's not only tough, it's ugly to watch to have a square root in the denominator. Okay. So this g of k, it becomes k plus 1 whole raised to 4 divided by the root of f of k. Sorry, not f of k. What did I do just now? The denominator becomes k times 2 plus k. Now I'm going to define a new variable p as k plus 1. So k will be equal to p minus 1 and p will be equal to k plus 1. I need you to note both of these because it will come in handy later on. So g of k will be equal to k plus 1, that is p. G of k is p raised to 4 whole divided by k. K means p minus 1 times k plus 2, that is p plus 2, p plus 1, and this becomes p raised to 4 whole divided by p square minus 1. Now we're going to apply the quotient rule and then we'll be finding the value of p. So for this quotient rule, what we have to do is to find the derivative of p raised to 4, multiply it with p square minus 1, then subtract the derivative of p square minus 1 by multiplying and then multiply p square with that derivative of p square minus 1 whole divided with p square minus 1 the whole square. So it will look something like, wait, by quotient rule it will be 4p cube times p square minus 1 minus the derivative of p square minus 1 will be 2p times p raised to 4 whole divided by uh, p square minus 1 the whole square, and since we are finding the minimum value of p, we need to equate this to 0. Okay, very nice, let's continue. So this will be 4p cube times p square minus 1 minus 2p raised to 5, and then the denominator goes to the other side and becomes 0. Okay, now we are going to take 2p raised to 3 in common, and I'll get 2 times p square minus 1 and minus what? P square, and this will be equal to 0. Now I'm going to take this to the other side and make it 0, getting 2p square minus 2 minus p square will be equal to 0, and p square minus 2 will be equal to 0, and p as root 2. Now if p is root 2, according to these above, we can express that k is a root 2 minus 1. K will be root 2 minus 1. Now remember that we had we had this. If I substitute the value of k, I will get t square times 1 plus k the whole square, which is what they asked us to find. So I'm going to just take this down here and I'm going to substitute the value of k. That will be 26 times 1 plus root 2 minus 1, that becomes root 2 the whole square. So times 2 divided by, now here's where it gets tricky, I need you to focus. K, it becomes root 2 minus 1, and 2 plus k becomes root 2 plus 1. So if I multiply both of them using a plus b into a minus b, I'll get 2 minus 1 inside the square root, which is 1. The square root of 1 becomes 1. So the denominator in this case becomes 1. That's very nice. I don't have to worry about a square root anymore. God, rationalizing the denominator is annoying. So 26 times 2 becomes 52. So the minimum value of x plus y times y plus z is 52, and that is the answer to our question. The answer is 52. Alright, that's it.